In this video, we're going to cover some core review of fractions. Although this isn't a part of our course, meaning a section that we need to go through, it's considered fundamental review that typically gives the most trouble. So I want us to go through these three problems, and my suggestion is once you feel like you have a bit of a grasp of what's going on, pause the video and attempt to try these on your own. And it might even be worth doing that right now just to see if you understand some of the concepts on your own. Okay, so let's begin with number one. We're multiplying 2/15 times 3/8. When you're multiplying fractions together, you can just multiply straight across, meaning multiply the top values together and put that over the multiplication of the bottom values together. But if you notice in this problem, we're going to end up getting some decently large numbers. And if these numbers were both double digits, meaning 15 and 27 for instance, then these would be very large numbers to start dealing with in a fraction. So instead of just immediately going to multiplying straight across, we instead want to see if we can reduce any of these fractions. So we're going to start with each fraction separately. We want to check, is there any common multiple between 2 and 15? There is not a common multiple, meaning there's nothing that divides 2 that also divides 15 evenly. So this fraction is simplified. Now we'll check the second fraction, 3/8. Again, there's nothing that divides 3 and 8 evenly. So this second fraction is also simplified. The last thing that we're going to check is there any common multiple in the top of either fraction that is also in the bottom of either fraction? Meaning, let's start with this 2 here. Is there a common multiple of 2 in the bottom of the second fraction, meaning this 8? And there is. Each of them has a multiple of 2, meaning each of them is divisible by 2. So we're going to divide each of these numbers by 2, and it keeps the problem exactly the same as it was before. It's just a little bit more simplified. So 2 divided by 2 gives us 1. I'm going to rewrite that. This way it doesn't look like a 12. And then 8 divided by 2 gives us 4. So just to go through that one more time, 2/15 times 3/8 is the same thing as 1/15 times 3/4. That is the exact same problem. Now let's check with the 15 and the 3. And again, we can see that there is a common multiple on the top and bottom. 15 is divisible by 3. So we're going to divide each of these terms by 3 to give us 5 and 1. So if we rewrite the problem again, we're left with 1/5 times 1/4. And now there is nothing else that can cancel. There's no common multiple between the top and the bottom in either fraction. So it's at this point that we want to multiply straight across, which gives us 1 times 1 is 1, over 5 times 4 is 20. And because we canceled all of our common multiples before multiplying together, this is completely simplified, so we don't need to reduce it any further. Now let's try the second problem. Addition is a bit more work when you're simplifying or solving fractions. When you deal with addition or subtraction, you need your denominators to be equal. You cannot combine fractions unless you have the same value in the denominator. So, because we're adding all three of these terms together, we want to find a least common denominator between all three terms. Meaning we want to find the smallest number that 4, 2, and 5 each divide into. And there are a lot of ways that you can go about this. One of the ways that you can do this is to break up every denominator into its prime factorization. So for instance, 4. 4 is the same thing as 2 times 2. Each of these are called prime factors because they're only divisible by themselves and 1. 2 is already a prime factor, so we can't break it down any further. So this 2 right here is going to stay exactly as it is. And finally, this 5 is also a prime factor, so we can't break that down any further. So whenever you want to find your least common denominator, once you've written out all of your prime factors, you take your first number. So this 2 times 2 represents our 4. We're going to take this 2 times 2, and now we're going to check if there's anything in any of our other numbers that we don't already have. So for instance, we'll go to this 2. Do we have a 2? Yes, we have 2 of them. So we don't need to include this 2. It's not needed. Now we'll go to the last number. Do we have a 5 in our LCD? We do not have a 5. So we need to multiply a 5 into our LCD. Now we've taken care of all of our possible prime factors that could go into our LCD, meaning that our least common denominator, or LCD, is the same thing as 2 times 2 times 5. And if you multiply that out, 2 times 2 is 4, times 5 is 20. So, that's one way to find the LCD, and it's definitely going to be one of the fastest ways. A much slower method for finding the LCD, which I don't recommend if you have large numbers, is to take each of your numbers again. So 4, 2, and 5, and start writing out all of their multiples until you find the smallest multiple that matches between all of your numbers. So for instance, 4 times 2 is 8, times 3 is 12, then 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, and now we'll go down to this 2. 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and you'll just keep doing this. Times 5 is 10, times 6 is 12, and you'll notice why this method takes so long, because we're going to have to keep going until we get a number that matches between all three of them. And now finally, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and it's at this point, if you were using this method, that you would notice 20 comes up in all three of these multiples, meaning 20 is the smallest multiple of all three of our denominators, so it is again the least common denominator. I really don't recommend this method beyond just your initial practice trying to learn how to do a least common denominator, and I really suggest you consider using this top method up here. Okay, so now that we have our least common denominator, we can start solving this original problem. 1/4 plus 1/2 plus 1/5. In order to solve it, we need to get all three of these denominators to be 20. And in order to do that, we have to multiply them each by some value. So for instance, 4, in order to make that 20, we have to multiply it by 5. But when we multiply 4 by 5, we've changed this problem, we've changed the fraction. So in order to keep it the same, we have to multiply the top of our fraction by the same number. If you multiply it to the top and the bottom, it's the same thing as multiplying by 1. So this keeps the problem the same. Now we'll go to this one. We need this 2 to become a 20, so we have to multiply it by 10. And again, in order to make it where we didn't change the problem, we have to multiply the top by 10. Finally, we have to deal with this 1/5. So to make this 5 become a 20, we will multiply it by 4. So we also multiply the top by 4. So in all, this ends up giving us 5 times 1 is 5 over 20, plus 1 times 10 is 10 over 20, plus 1 times 4 is 4 over 20. And now that we have a least common denominator between all three of them, meaning all three of their denominators match up, we can add all of the top numbers together. So that gives us 5 plus 10 plus 4. And we put that all over one denominator, which is 20, which leaves us with 19 over 20. And we just want to do a quick check to see if this will simplify, but we can clearly see that 19 and 20 do not have any common multiples, so this will not reduce, giving us a final answer of 19 over 20. Okay, so obviously there is a lot more work that goes into adding and subtracting compared to multiplying fractions. The last problem is going to be to perform order of operations on these three fractions. We are dividing and adding these fractions together. So I suggest that you pause the video and take a try at going through this problem. Okay, so hopefully you've tried it by now. Now let's try this together. Whenever you're dealing with division and addition at the same time, the first thing that you want to do is change this division to multiplication. Whenever you are dividing two fractions, you want to start, let's go ahead and write this out. You want to take your fractions, so let's say if we had A over B divided by C over D. In order to change this to multiplication, you have to take your first fraction and rewrite it. And then you're going to change your division to multiplication. And then you're going to flip your second fraction. So you'll end up getting D over C. So A over B divided by C over D is the same thing as A over B times D over C. This is called the copy dot flip method, meaning you copy your first fraction, you change your symbol to a dot for multiplication, and then you flip your second fraction. So keeping that in mind, 1/3 divided by 1/6 is the same thing as 1/3, we copy, then we dot, meaning we multiply, and then we flip, which gives us 6 over 1, plus 1/2. Now, before we continue, one thing that I should have mentioned here is the reason why we're doing the division to multiplication first. So remember, whenever you deal with order of operations, division and multiplication always come before addition and subtraction, meaning we have to divide these two terms before we can add this term, this 1/2. Okay, so back to it. 1/3 times 6 over 1 plus 1/2. We're multiplying these fractions together. And remember, we want to check if there's anything common between the top and bottom. So 3 and 6 are each divisible by 3, so we're going to take care of that first. 3 divided by 3 gives us 1. 6 divided by 3 gives us 2, which leaves us with 1 over 1 times 2 over 1 plus 1/2. And I know at this point it's tempting to want to cancel these 2's out, but notice that we're adding here. So you cannot cancel if you're adding or subtracting, only when you're multiplying. So now we can multiply these fractions together since we already simplified. We'll multiply straight across to get 1 times 2 is 2, over 1 times 1 is 1, plus 1/2. And now for our final step, we want to get a least common denominator to add these fractions together. So what's the smallest number that 1 and 2 can divide into evenly? That's going to be this 2. You could go through either of these methods to check really quick, but whenever you have a 1 and another number, the other number is always going to be the LCD. So to get this 1 to become a 2, we're going to multiply it by 2. And when we do that, to keep this problem the same as how we started, we're going to multiply the top by 2, which gives us 4 over 2 plus 1 over 2. And now we're going to keep the denominator, which is 2, and add the top values together, the numerators. So we get 4 plus 1 over 2, or 5/2. So 1/3 divided by 1/6 plus 1/2 is the same thing as 5/2. This doesn't simplify any further, and we do not want to change it to a mixed number. You always want to leave it as an improper fraction. Improper fraction meaning that the top value is larger than the denominator.